My previous class, I talked about the definition of groups. So decomposition is a group having few properties. We came across few of the important terms related to groups like order of the group, order of a group. Then while discussing with that, we came across two extra terms like finite group and infinite group. So in case of finite groups, we have seen already a few examples like SN. Few of you have already talked about Klein's 4 group. We denote it by K4 and so on. For infinite group, we have already talked about Z plus, Q plus. So set of all rational numbers with respect to addition. Few multiplicative groups like set of all non-zero rational numbers. We call it Q star, or set of all non-zero real numbers with respect to multiplication, or set of all positive rational numbers with respect to multiplication, and so on. So for infinite groups, we have already witnessed many of the examples. For finite groups, we haven't dealt with many, but today we'll look forward another important class of finite groups. Another term we have heard about is order of an element. Order of an element. And there we have already seen that the smallest positive integer n, such that in, say, if it is an additive group, na equal to 0, then this will be said to be the order of the element. Okay. So order of an element, say a, then we call it, this is the smallest positive integer such that na equal to 0, where 0 is the identity element. Identity element, or na equal to e, where e is the identity element. And if no such n exists, then we call the order to be infinite. So order of an element might have two different parts category. If such n exists, we call it order to be n, order as n. If no such n exists, no such n exists, we call order as infinite, order as infinite. Some of the authors, they also sometimes say order 0, but popular one is infinite order. For example, in case of say S3, we have already seen order of say 1, 2, 3 cycle is 3. Similarly, say in S11, order of say 1, 2, 3, 4, and maybe 8, 9, product of 2 cycles is, what is the order of this element? Can anybody tell me what is the order of this
Four,
product of 2 cycles in S11? Yes,
four,
tell me.
four,
It's 4.
four.
Four.
Exactly. So as I mentioned, I haven't proved yet, but you may try with this proof the order of elements of some product form. If it's a product of two distinct disjoint cycles, most importantly they are disjoint cycles, then the formula would be LCM of order of this and order of this. So as this is a single cycle, the order of this element will be 4 and order of this element will be 2. So LCM of 4 and 2 is 4. So we are done. So we only talked about the result, but not yet proved the formal way how to prove this. Initially, my intention is to give you the basic ideas of what groups are, how these elements can be multiplied or can be added or can be composed. Once you have a clear idea about this kind of groups and you are able to deal with the elements of these groups, then the proofs will be quite easy to all of you. That's why I haven't taught much about the formal definitions or formal things. Initially, I go for informally so that you will all get the some idea about it. Okay. Okay, let's increase it a bit. Yeah. Okay. Then what we talked about initially these two things. Today we will again go for another important example of a group, and from there we will derive some important extra properties. Okay, so we all know about Z. So Z plus is a group, and say this is the whole integer line of which this is our 0. Say this is our 1, say 2, 3, 4, and so on. And here also we have -1, -2, -3, and -4, and so on. So this is an infinite line with 0 here. Now take any integer, positive integer. For example, say I have taken n to be 5. Now if I ask you the question, divide all the integers that are present in Z plus. So the Z plus is a group. Take all the integers and divide it by 5. Then, as we know, when we are going to divide any integer by 5, what could be the possible remainders? Can anybody tell me what could be the possible remainders? If I
0, 1, 2, 3, 4.
2, 3, and 4. So see, they are 5 different remainders that one could have if I divide any integer n by 5. If I divide n by 5, then the remainder could be any one of them, 0, 1, 2, 3, or 5. Okay. Now what I am going to do is take any integer n and divide it by 5, and consider 5 different boxes. So this is the box for 0, this is the box for 1, this is the box for 2, 3, and 4. Okay. So they are the 4 buckets which corresponds to the remainder of this any integer divided by 4, and consider the corresponding remainders. For example, if I divide 0 by 5, I will have 0 as a remainder. So this 0, I will put it here in this bucket. Similarly, if I have 1 and if I divide it by 5, the remainder will be 1, and then put it in this bucket. For example, I have 5. If I divide 5 by 5 and consider the remainder, then suddenly 5 will go inside this bucket, because here the remainder is 0. Similarly, if I have 6 here, then 6 will certainly come to this bucket. Similarly, 7, and so on. So in this 0 bucket, what could be the elements? Like 0, plus minus 5, plus minus 10, plus minus 15, and so on. Okay, so there are infinitely many elements within this bucket. If I consider 1, then you can understand that who would be the elements here in 1, 1, 6, then 11, then 16, and in case of negative element, what elements would be here? Can anybody tell me? For negative elements, which element will come here in the 1 bucket? Which element will come here in negative 1? So will -1 come here?
Yes, sir.
Anybody? Will -1 be here, or -4 will be here in this bucket? Okay, let's have a look. If I have -1 and if I divide it by 5, what would be the remainder? What would be the remainder? What is the quotient? Tell me, what would be the quotient and what would be the remainder? That is really a tricky question. Okay, so I have already taught you, but if I ask you this question, what would be the remainder and what would be the quotient? Can somebody tell me what would be the quotient? So this is quotient would be how much?
0.2.
0.2. We are all in integers. Within this integer, we are not in fractions. First of all, can you divide -1 by 5? Is it really possible? And if so, then what would be the remainder or what would be the quotient? Any response? Well, now you can understand that this is really a tricky question, and that will lead to you to the maybe class 3 or 4 where you start doing divisions, even maybe class 2. So it would be a high jump or even be a triple high jump to shift you from undergraduate level to class 2, 3 or 4 maybe. What would be the remainder when you are going to divide? Anybody?
Quotient will be 0.
Okay, somebody says quotient would be 0. Then what would be the remainder?
So -1.
Okay, -1 would be the remainder. But just now you mentioned that some of you have already mentioned that when you are going to divide it by 5, these are the only remainders 0, 1, 2, 3, and 4. But you have already given me another remainder -1.
Sir, quotient 1.
Okay, somebody says quotient would be 1. Just a minute, I will change the color. Somebody says quotient would be 1. And what would be the
Remainder
remainder?
4.
Okay, so if quotient is 1, then that means this is 5. So quotient 1 means how much this? This is 5.
Sir,
And
quotient
this is,
-1.
yes, now you are right. So quotient is -1. Then this value is -5. And when you are going to do this, you have to change the sign. Actually, you are subtracting it, that becomes 5. As a result, it will 4. Now is it clear? So 5 can be written as -1 into 5 plus, sorry, not 5, it's -1, sorry. I must write in this way. -1 can be written as -1 into 5 plus 4. So that's the definition of, so you have already forgotten, that's the definition of division algorithm or division algorithm statement, what you have already learned in your maybe 10th, 12th, or maybe class 1 and 2, that if a and b, a and b are two integers with b not equal to 0, then their exists quotient and remainder belongs to z, that means integers, such that if we are going to divide it by b, then a should be written as bq plus r, where this part is very important, where most of you miss. 0 less than equal to r, strictly less than, what should be this value? Strictly less than,
B.
not b, it's mod of b. Because if you write b, then you can never divide. Say you are, if you are going to divide like this, is it really possible? Can you divide 2 by -5? Theoretically possible, but then what would be your remainder? Because in that case, if I write like this is strictly less than b, then your b is -5, and that would be a contradiction. 0 less than equal to r, strictly less than b, that means -5, whereas -5 in that case will be greater than equal to 0, which is not possible. So the actual statement would be b should be mod b. Many of you miss this, and it's sometimes they are asked in competitive exams interview that how much you know. So you all know these things, but sometimes if I ask you this kind of tricky questions, then you face a lot of difficulties or problems. That is one of the reasons being, when you study this, you do not take into account very seriously, because they are very small issues, but they are very important issues. Many of the books, they say that b is strictly greater than 0. Here What I have done, b not equal to 0, many of the books they say that b greater than 0. In that case, you don't need to put mod of b. But in that case, you may ask you this question, is it really possible to divide, say, 2 by minus 5? Theoretically, it is really possible because you can, of course, divide this. Now, can anybody tell me what would be the quotient and what would be the remainder? If I divide 2 by minus 5, then what would be the quotient and what would be the remainder? Quickly, quickly, again a test. Oh, you're taking so much of time for division. Don't tell your junior brothers or your nephews that you are taking so much time in division. That too, 5 and 2 dealing with.
So quotient
Now tell me. Now you know this. Quotient
quotient
is
0 and remainder 2.
oh, with a remainder. Yes, correct answer. So in that case, you can write 2 in terms of this minus 5 into 0 plus 2. See, all the properties are satisfied. Mod b is now 5, remainder is your 2, and which is less than equal to this, and you can write in this way. Okay. So unless you put this condition, you will have lots of confusion and you will find that you will get different remainders and different quotients. So that happens due to this misconception. So you have to be a little careful while dealing with this kind of thing. So I have plenty of such examples where usually the students are confused, and when they are confused, sometimes the marks are deducted. So when you give this kind of answers, -1 and something, at the exam hall you find that you have done correctly, but actually you have done a mistake. But sometimes people they commit mistakes intentionally. I mean, not intentionally, but unforced error sometimes happens. So they are kind of unforced error. So you know almost the same thing, but due to lack of a single information, this kind of confusion may occur. And sometimes you might have, so you are supposed to write 3, by mistaken, or due to some mind problem you might have written 4. So they are called basically silly mistakes. And during this exams, you might find that you may have lots of this kinds of problems. So you have to be little careful about this kind of things because they actually deducts a lot of your marks and your score becomes. I mean, it doesn't reflect as much as you can. So you have to be little careful. Okay. So let us again come to my original problem. So let me make it a new. Okay, let me. Okay. So again from home. Okay. So what we are trying to do is that we had initially, as I have, so this is my 0, this is my 1, this is my 2, 3, 4, and so on. Here I had -1, -2, -3, -4, and so on. So it's up to infinity. I mean, you cannot stop. What I did, I had 4 buckets. I have chosen n to be 5. That's why I have 5 buckets. If I have taken 6, then I could have 6 buckets. So I had now 5 of these buckets. So here I can see that 0, plus minus 5, plus minus 10, plus minus 15 are, there are infinitely many such elements. So here I can see that 1, 6, 11, 16, and in case of negative, tell me few negative elements quickly. Few negative elements quickly, which will give you 1 as a remainder. So this is 4
-4.
-4, then minus
9.
-9 minus, then you can add 5 in terms of minus, then -14 and so on. Similarly, you can see that 2, then 7, then 12, 17, and in case of minus, you can see -3, -8, -13, and so on. Similarly, for so each of this box, each of this bucket will contain infinitely many such elements. So 3, then 8, then 13, 18, and -2, -7, -12, and so on. So here 4, then 9, then 14, 19, -1, -6, -11, and so on. Okay, so there are plenty of such elements. Okay, so now what I understand is that each of these buckets, they contains infinitely many elements, but the number of buckets are 5. So 1, 2, 3, 4, and 5. Now just rename these buckets with a kind of leaders. So you can think of, since this is an election time, so you can think of there are 5 different parties are there, and each of these parties, they do have a representative. We call it neta. So they are the kind of leaders of these parties. So I just make them bold. So 2 is the party leader, 3 is the leader of the party of this bucket, and 4 is the leader of this bucket. Some of the books, they put some extra maybe thing like bracket of this form. Some of the books give a kind of cap on them. Okay. So what we are going to follow here, we are going to follow this left and right bracket. So what we had basically 5 different parties, 3 and 4. So this is a set. We call this set as Z modulo 5. Okay, so Z modulo 5. So till now we have a set. So our main intention is to basically convert this set into some group structure. That means we need to have some kind of addition which would be defined on this political leaders. So they are the leaders, okay, and this corresponds to the party. So this leader corresponds to the whole box or whole party members who are the members of this. Similarly, this leader 1 represents whole of this number, and so on. Okay, now how to define these numbers? The definition of class is very trivial, easy, quite easy. So what I do, I'll just take say some element 1 and may take some element 4. What I'll get? I'll get basically 1 plus 4 and then box, and that becomes 5, and 5 is within this box, that means within 0 leader. Or take any element, say take any element from, say take any element. Somebody, can you tell me any elements from this group other than 2? Somebody, any element, any party member's name from this group, any number?
17.
17. Okay, and then plus, say take any element from here. Anybody tell me any element from here?
19.
19. Okay, so if I just add them, what I'll get? I'll get 36. What I'll get 36, right? Now try to find 36 will be in which group? 36 will be in which group?
Box of 1.
36 will be in here, right?
Box of 1.
Yes. Okay. So instead of dealing with taking 17, if I consider the leader of it, so who was the leader for 17? The leader for 17 was 2, right? And leader for 19 was 4. And if I add them up, what I will get? 6, and that means 1. So what I get, instead of dealing with each of this party member, instead of dealing with each of these party members, it is sufficient to deal with their leaders. That means 2 and 4. So instead of considering each of this party member, if you deal with the leaders and just add them up, you will end up with the same answer. Okay, so that's the idea. So idea is, instead of considering any element, just have a look at the who is the leader of this class, and take any elements from any party members. Just have a look at who is the leader of that party. Just add them up. What would be the result? That will be the result of individual addition of this individual party members. So it is sufficient to have the party leaders. That's why we have only this leaders, and these leaders are basically forming this group Z5 with respect to this addition just now I have defined. Okay, so this can also be seen in this way. So we have Z, right? This is our whole Z. That means whole of integers. Some 1 is there, 2 is there, 3 is there, maybe 4 is there, 0 is here, and so on. Now I just define a relation on Z divisible by n. Sorry, n equal to say 5. Okay, then you can understand that 1 and 6, they are related, because 1 minus 6, that is minus 5, minus 5 is divisible by 5. Similarly, 10 and 30, they are related, because 10 minus 30 is minus 20, which is divisible by 5. So very easily you can check that this row is an equivalence relation. Then as a result, you can understand that the whole set Z will be partitioned, right, if it is an equivalence relation, and it will be partitioned like this. So each of this, it will contain infinitely many elements. Each of this will contain infinitely many elements, and this set corresponds to 0. We are denoted it by class. So they are now becoming all class, and all these classes are disjoint, because this set consists of say 2, 7, 12, etc. This set, and say if I consider this set, which will be 1, 6, 11, and so on, these sets, their intersection is exactly empty. And if you consider union of all these sets, you will ultimately end up with Z. That's why this is also an equivalence relation on Z, forming a partition, and these partitions are like class 0, class 1 to class 4. Okay, so this group is very well known, and that is known as Z in general. If I consider it instead of 5, if I consider with n, with respect to this group, is known as addition modulo n. Okay, so now we can understand that if n is say greater than equal to 2, then what would be the order of Zn? Can anybody tell me what would be the order of Zn? If n is greater than equal to 2, what would be the order of Zn? It will be n, because it will contain, Zn will contain basically class 0, class 1 up to class n minus 1. So starting from 0, it goes up to n minus 1. As a result, this is a group containing n elements. So this is an example of a finite group. Okay, finite group. Now let us have a look at this. Okay. Uh, okay. So all of you know about clock. The normal clock that we usually wear, not the electronic one, the clock that we usually have. So it start with say 1, 2, then 3, 4, 5, then 6, then 7, 8, 9, 10, 11. Sorry, it should be 12, and say 1 comes here somewhere. Okay, so this is our clock. So now if I ask you the question, with this clock, which group that you can associate? Any group that you can think of that can be associated with your clock? Any group that comes to your mind that could be associated with the group, some group? Any idea? Okay, if I ask you,
Addition modulo 13.
sorry,
Addition modulo 13, but 0 will be included in the clock.
okay, somebody says addition modulo 13. Okay, it was a good try, but some better idea. How many elements will be there? Addition modulo 13. How many elements?
12 with 0 included.
So there will be 13 elements, right?
Yeah,
But here you can see
13
that
elements.
here there are 12 elements. It starts with 1, it ends with 12.
If we include 0 there, then
It includes 0, but 0 is not here. Okay, but it was a good try. Okay, now I can give you an hint. In this clock, have you ever asked the question why you do not have the time 13, or why you do not have the time 14? It always from 1 to 12, and then again 1 to 12, and again 1 to 12. You can never have 13 or 14 here. So in railway or in airport, you might have heard or might have seen the clock of, instead of 12, you might have 24 hours clock. So there I may also ask you the same question, why in that 24-hour clock, why you do not have a time like 25 or 27, something like that. Here also you won't get 13 or 14 in 12-hour clock. Similarly, why you do not have 15 or 17 in your clock having 24 hours. Now can you give me which group shall we associate with this? She has given a very good try.
Z12, then like Z12, then and we'll take like 12 as 0. The
Yes.
next.
So if I consider this group, then this will have 13 elements, right? Sorry, 12 elements. This will have 12 elements. Who are these elements? Starting from 0, 1, 2, plus 11. So up to this we are done. Now the question is, this does not have 0, whereas it has 12. So why don't you put like this? Because they are the same within the same class. So in 0 group, 0 class, you will certainly have 12 inside. So why don't you have like this? So then the thing is very easy or very clear to all of you. Like if I have, say, currently the time is 3:47, maybe say 3:47 p.m. Now if I ask you the question, so suppose I approximated with 3 p.m. and if I ask you this question, say after 11 or 12 hours, after 12 hours, what would be the time? Then you will say suddenly it would be 3 plus 12 hours, that means 15. And if I consider all of them as a class, then this will be class 3, right? Similarly, if I ask you, so that will be again 3, then not PM, but it will be 3 AM, because it only added 12 hours. But from group theoretic viewpoint, if I consider this is as a class and this is also as a class, then addition of this 2 is nothing but class 3. So class 3 plus class 12 is nothing but class 3. You can also think of class 12 as class 0. So class 3 plus class 0 becomes class 3 plus 0 class equal to class 3. So different way you can explain the whole thing. So in my next class, I will show you few of the applications in security. That means in cyber security, not in a very new cyber security schemes, but I will show you how the cyber security was somehow related to this kind of clock system. Okay, in my next class, I will show you all. Okay, so now what we get another group which is Zn addition modulo 2, and from your very childhood, from when you started wearing your clocks or watches at your hand, you are basically known to this group, but unknowingly you didn't thought about it, but from now on you can understand that you are very strong in this kind of groups because you have already started exploring the ideas of this group from your childhood. Okay, now let us try to have some extra property of this, and that will lead to a very important term of abstract algebra. Okay, first let us try to have a look at if z5. Okay, z5 plus. Now you can see that there is one element. So which are the elements? The elements are class 0, class 1, class 2, class 3, and class 4. So they are the four elements. Now I can see that some element is there. For example, class 1 is there. If I add 1 two times, say if I add 1 times, I will get this element. If I add 2 times, 1 plus 1, I'll get this element. If I add 3 times, 1 plus 1 plus 1, I'll get this element. If I add 4 times, 1 plus 1 plus 1 plus 1, I'll get this element. And if I add 5 times, 1 plus 1 plus 1, mind that we are in Z5, what I'll get? I'll get basically 5Z, sorry 5, and that is nothing but 0. That means I get back to this element. Okay, so what I want to say, that with the single element, if I add up with few number of times, I will be able to generate all the remaining elements. So with class 1, I can generate class 1. With class 1, by adding 2 times, because addition is my operation on that group, by adding 2 times, I can have 2, adding 3 times, I can have 3, with 4, I can have 4, with 5, I can have 0. That means this element is a special element which has the capability to generate all the remaining elements. That's why this element is known as generator of the group Z5 plus, right? Any question up to now? So the next question is there any other generator? Is there any other generator of Z5? Let's have a look. Okay, let's try with any other element. Which element would you like to test? Anybody? Any other element 0 and 1? Okay, any other element somebody can suggest?
So 3.
Okay, somebody says 3. Okay, so 3, so this is done. If I add 2 times, 3 plus 3, that becomes 6. That means class 1 in Z5, right? 6 and class 1 is the same. So 1 is also done. If I add 3 times, then becomes class 4, and class 4 becomes class 9, and that becomes class 4. That means this is also done. If I add 4 times, so it added 1 times, this is 2 times, this is 3 times. Now I'm going to add 4 times. 4 times class 3 means class 12, and that is nothing but class 2. Okay, so 2 is also done. Now I add up 5 times. Sorry, class 3 adding up 5 times. That means class 15. And that becomes 0. So I get all the elements. So you can see that 0, 1, 2, 3, and 4. I can able to generate all the elements by considering this. So as like 1, this is also a generator. So you are quite lucky in that way. You get a generator, right? Now I request anybody else to tell me any other number except from this 1 and 3. Anything? Somebody come up with some number. I was lucky because I get 1. He was lucky because he got 3. Anybody else? Any other number from 0 to 4? Somebody came up with
Sir, 4.
4. Okay, let's try with 4. What is your intuition? Will that be a generator?
Yes, sir.
Okay, let's see. So 4 generates 4. If I add up 4, that means 8, which is nothing but class 3. That gives me this. If I have 3 times, then 12. That gives me class 2. If I add up 4 times 16, that gives me class 1. And if I do 5 times, that becomes 20, and that is 0. So you can see that 4 is also a generator. Now you can check that class 2 will also be a generator. Okay, so you had already 4. Now who is left? 0 is left. Do you think that 0 is also a generator? Do you think that 0 is also a generator or not? True or false?
False.
False. Because if you add up 0 2 times, you will again get 0. If you add up 3 times, then also you'll get 0. You cannot go out of 0 if you add up them many times. It doesn't matter. So 0 is not a generator. So what is your idea then? In Z5, except for 0, except for 0, all elements are generator. All elements are generators of Z5 plus. Is it clear to all of you? Okay. Then let's try with another group. For example, let's try with Z6 plus. Okay. So I will start with the simplest one, class 1. Is it a generator? You can see that class 1 can generate class 2, class 3, class 4, class 5, and then class 6 become class 0. So all the elements of Z6 can be obtained by using class 1. Okay, now anybody tell me any element other than 1? Anybody?
Sir, 5.
Okay, let's start with class 5. So class 5, it gives one element. Then if I add class 10, then it becomes class 4. So it's already done. Then 3 times class 15, and that becomes class 3. And then class 20, and that becomes class 2. And then 25, that becomes class 1. And then 30, that becomes class 0. So it gives me all the elements like 5, 4, 3, 2, 1, 0. So all the elements are generated from class 5. So class 5 is also a generator. Very good. Then any element that you want to start with? Any element other than this two? Anybody tell me any element? Any element other than this two? Okay, let's see 2. So if I add them up, 4. So 2 elements are exhausted, 2 and 4. Then if I add them up, 6, and 6 becomes 0. So 3 elements, doing well. Then if I have 8, that becomes 9. Add them up again, then that becomes 10, and that becomes 4. So again I'm getting 4, and again I'll get 0, and so on. So that means if I start with class 2 and if I add them up several times, what I'll get? I'll get class 2, class 4 and class 0, nothing else. You cannot come out of this 3. That means it will not have the ability to generate class 3 or class 5 or class 1. It will not be able to generate these elements. That means this cannot be a generator. So this can never be a generator, right? Is it clear to all of you? Now you have some idea about generator, and that actually leads to very important term that is known as cyclic group. So what is a cyclic group? Let G be a group if G contains a generator, then we call G as a cyclic group. That means any group having a generator is called a cyclic group. For example, Zn plus is a cyclic group. So tell me one generator of Zn plus if n greater than equal to 2. Tell me one class of Zn plus which is a generator, always will be a generator irrespective of n. Sorry, 1 is a cyclic group with generator class 1. That means it has at least one generator. That means Zn plus is always a cyclic group. Okay. So what we have found here, Zn plus is a finite group. Finite group also it's a cyclic group. So that part it's quite clear to all of us. Now question is a cyclic group commutative? So now I am going to abstract way. So now my idea is let G be a cyclic group. What does it mean? That means that implies G has a generator, right? Say G. What does it mean? Any element of G can be expressed in terms of G. Okay. So let G dot with respect to multiplication. Say G is a group, cyclic group. Now I consider let A belongs to G. Then by definition, A can be expressed in terms of G. How? Then there must exist some integer n belongs to Z such that A must be of the form G to the power n. Okay. So one may be little bit confused why this is power, and in Zn why it was like NA. So just now we have seen that, for example, in case of Z5, what we have seen that class 3 could be written as 3 into class 1, right? So this was my Z, and it was like 3 plus 1 plus, this is nothing but 1 plus 1 plus 1. Okay, that is why this n is here, not at the power. But if your group is multiplicative, then this plus will be replaced by dot. If you are having with any arbitrary group with dot, then class 1 dot class 1 dot class 1, and that means class 1 cube, not 3 class 1. If this is an additive group, then it will be 3 class 1, but if it would be a multiplicative group, then it will be on the power. As a result, this means G dot G dot G dot G n times. Okay, that's why this is on the power. If I write it plus, then it would be n into G. That means G additive added n many times, that will give you this A. Is it clear? Okay. So my question is G commutative? So to show the whether G is commutative or not, what you need to show? You need to show take two elements. Let A, B belongs to G. What you need to show? To show A dot B equal to B dot A for all AB belongs to G. Okay. Now somebody give me a hint or somebody tell me how to write formally. Now you should learn how to write. So first of all, tell me what is your intuition? Is G commutative or not? What is your
Yes, sir.
intuition? Okay,
Commutative.
Yes,
okay,
it's
okay.
Yes, sir, commutative.
Very good. So what we need to do is, I need to prove that G is commutative. I need to take two elements. So let AB belongs to G. Now I know that G is a cyclic group, right? Let G belongs to G be a generator of G dot. Then I can write A in terms of B, sorry, G and B in terms of G. Then A equal to G to the power N and B equal to G to the power M for some N and M belongs to Z. Then what I need to show? I need to show this. So I start with A dot B. Then put the value of A. This is G to the power N and this is G to the power M. The same G, so you can write it G to the power N plus M. Now they are in integer and this addition is addition of integers, right? Then you can surely interchange these two values because this plus is commutative. So G to the power M plus N. And then just break it down. And this is nothing but B and this is nothing but A. So you started with arbitrary AB and you have proved that arbitrary AB can commute. That implies A dot B equal to B dot A for all AB belongs to G. That implies G is commutative. Okay. So is it clear to all of you? Any question? If you have any question, please let me know. Okay, now a very quick question. Hope you understand it. Let us consider Z9 plus. Question is, how many generators are there? Quickly try to answer this question. How many generators are there in Z9 plus? Quickly.
6.
Six
Sir,
generator.
6.
Okay. So how do you get 6?
the 5 of 9. Like we do 9 into 1 minus 1 by 3. Like that, we can the divisors of 9 are 3. Only 3 is the divisor. So n is the number into 1 minus 1 by the divisors. Get it as the number of generators. It is 5 of the generator n or 9.
Okay, so what about the others?
Yes, sir. Like that 5 of n. Like suppose the n is the like order of the.
No, that's fine. I mean, anybody else? Anybody else could get this answer?
Because there
Sir,
are
the
the
prime. Uh, sir, there are the prime numbers to 9.
six elements which are prime with co-prime with 9.
Very good. So, as I understand, just now we have talked about Z7 and Z6. Z7, sorry, Z5, I guess, Z5 and then Z6. So in case of Z5, we have seen that class 1, class 2, class 3, class 4, all of them, they were the generators. But that was not exactly the case in case of Z6. So here we have seen only class 1 and class 5 are the generators. Why they are so, it will be a proof. I am not going to the details of the proof for the time being, but surely after a few days, maybe after a few classes, we will do that. But you can understand or observe one thing, that all these elements, class 1, 2, 3, and 4, all of them are relatively prime to 5. 1, 2, 3, and 4. Relatively prime means GCD of 5 and any of them is 1. Similarly, you can see that 1 and 5, this GCD is 1. 5 and 6, this GCD is 1. But 2 and 6, their GCD is not 1. Their GCD is 2. That's why 2 can never be a generator of this. Similarly, 4 can never be a generator of this. By similar argument, 0 can never be an element or never be a generator of this. So that's why you can understand that class 3 can also never be a generator, because GCD of 6 and 3 is also not 1. As a result, they are discarded. So the question is, if I ask you this question in a general format, whose proof I will do maybe after a few classes, that in Zn, how many generators are there? How many generators are there? So in one sentence, if I write it, this is phi of n, where phi is Euler phi function. Euler phi function. So the question is, what is Euler phi function? Can anybody define what is Euler phi function? Have you done this Euler phi function in any of your courses? Anybody? You may not have encountered with this Euler phi function. The definition is very easy. So suppose let n is greater than equal to 1, then phi of n equal to the number of positive integers which are less than equal to n and relatively prime to n. So what is this definition? Phi n is the number of positive integers which are less than equal to n. Mind that this is again very important, and relatively prime to n. So that's why what is phi of 9? Phi of 9 means number of integers which are less than equal to 9 and relatively prime to 9. What are they? They are basically, so the cardinality of this set, 1 is relatively prime to 9, 2 is relatively prime to 9, 4 is relatively prime to 9, 5 is relatively prime to 9, 7 is relatively prime to 9, and 8 is relatively prime to 9. And this is nothing but the cardinality of this set, and that is 1, 2, 3, 4, 5, 6. That's why the cardinality of phi n is, sorry, the value of phi n is 6. And that's why when I ask you this question, it was actually phi of 9, and phi of 9 becomes 6. Clear? So when we will deal with phi in more detailed way, then we will able to understand how to calculate this value of phi n more efficiently. So if I ask you this question, can you tell me what would be the value of phi of 101? Note that phi of this 101 is a prime number. Can anybody tell me what is this value, phi of 101? I tell you 101 is a prime number. Yeah. Then you can understand that this value will be 100, because except for 101, all of them are relatively prime to 101, right? So it starts from 1, 2, dot, 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 100. All of them, these 100 numbers, all of them are relatively prime to 101, except for 101. Because why I have taken this less than equal to, it will be clear if I ask you this question, what is the value of phi of 1? So number of positive integer less than equal to 1 and relatively prime to 1, that is 1. That's why phi of 1. Some of the books, they don't mention less than equal to, they put it just strictly less than. But in that case, they also mention one extra thing, phi of 1 equal to 1. Okay. But in my definition, just to avoid the extra thing, I just incorporated less than equal to. And that also includes phi of 1 equal to 1. That's why this definition is more sleeker than most of the definitions that are available in many of the books. Is it clear to all of you? So what you understand now is that the number of generators of a cyclic group is quite important. Okay, so till now what I understand is Z in is a cyclic group. Cyclic group, it's a finite cyclic group. Okay. Now, can you somebody give me an example of an infinite cyclic group? Can somebody give an example?
Z plus.
Okay. Somebody says Z plus is an infinite cyclic group. Can tell me who are the generators of Z plus?
Sir,
Yes.
one and minus one.
Okay. So 1 and minus 1 are the generators according to him. Very good. They are correct. Now tell me, how can you express minus 7 in terms of this generator? So minus
Sir,
7
minus
belongs
one
to,
plus.
yes.
Sir, minus one plus minus one. 7 times minus one actually.
No, what I tell that I consider 1 as your generator, right? So you must express any integer of Z in terms of 1. That is the concept.
Yes, sir.
Now, okay, now tell me minus 7 is within Z. So according to your definition, minus 7 can be represented in terms of 1. So this is the notation we usually use for generator. So this means generated by 1. Okay. So minus 7. So this is Z. Z is generated by 1. So this is my generator G. Now minus 7 belongs to Z. So according to your definition, minus 7 should also be represented as some n into G, right? So how can I explain it? Yes, you are right, but tell me properly, because you are using minus 7, but I am using 1. 1 is my generator. Now how can I express minus 7 as by using 1? So if you remember my definition, what was my definition? My definition was, if G is generated by this group G, then let A belongs to G, then there exists some integer n such that A must be of this form, right? Because G is my generator, where this is an integer. Now I consider this to be a multiplicative group. But here Z is an additive group. Now tell me, how can I write minus 7 in terms of G into something, and this G is my 1. So what should I put here?
minus 7.
Minus 7. It is not the meaning that 1 is added minus 7 times. You cannot add 1 minus 7 times. Can you add? you can always add positive terms. So what does it mean actually? So that is very important. So in A, if A is any element of G, okay, and I am considering say additive group, what does it mean? It has three different meanings. A plus A plus A n times if n is greater than 0. This is an integer. If this integer is greater than 0, then I can have A plus A n times. If this value will be 0 if n equal to 0, and this value is minus A plus minus A plus minus A if n is less than 1. What you told initially was perfectly correct, but I just want to make you sure that it does not mean that 1 plus 1 plus 1 minus 7 times. This representation actually means if this value is negative, then you just make a minus A. Okay, then minus A how many times, or this may be, you can say this is minus n times, because n is your negative, so minus A is positive, and then this is minus n times, and this value will be minus plus minus A minus n times, and that will give you the value of this. Is it clear to all of you? Now you can understand minus 7 into 1. What does it mean? It means minus 1 plus minus 1 plus minus 1. This is minus of minus 7 times. That means 7 times. So minus 1 7 times, that gives you minus 1 minus 7 into 1. Is the notation clear to all of you now? Clear? Very good. So let's come to this group. So this group is a cyclic group which is generated by 1 and minus 1. So we have two different kinds of infinite group, infinite cyclic groups. So we have seen two different types of infinite two different types of cyclic groups. One is finite, another one is infinite. So infinite. So finite and infinite. And this is cyclic group. Okay. So finite group, we have seen that Zn plus, and for infinite cyclic group, we have Z plus. So afterwards, when we'll go further, we'll consider another concept called isomorphism, which I will consider later on, but not for the time being. But we'll show that these two groups are not isomorphic. We'll show that, and we'll show that if you have, suppose n equal to 17, you will get only one cyclic group which is known as Z17 plus. That I will come to later on. But up to what I have done, is it clear to all of you? Is it clear to all of you till now what I have done? Any question or queries? Okay. If not, then let's come to another part of it. Say previously we have already heard about GL2R, right? So this was all 2 by 2 matrices such that A, B, C, D belongs to R, and AD minus BC not equal to 0. We have seen that with respect to multiplication, this forms a group, right? GLN2R with respect to multiplication, this forms a group. Clear to all of you? Okay. Now, instead of this, if I consider GL2Z2, remember, so here it was R, now I consider this as Z2. Now, how they should look like? So, class A, class B, class C, class D, such that all of them, class A, class B, class C, class D, they are all belongs to Z2 class. Now I consider with respect to multiplication. So this is a set and I consider this with respect to multiplication. The question is GL2Z2 a group? What is your intuition? What is your intuition? So what was few important properties of this group? This group was infinite. This group was non-commutative. Today some of you told me non-commutative. So these two properties we till now we know about this group. Now what's about this group? Is this group infinite? What is your intuition? Or first of all, is this a group? And if this is a group, what are the elements? Okay, first let's try to calculate these elements. So GL2Z2. Can somebody tell me what are the elements here? How many elements are there? Some elements. I'm giving you one element. So this is class 1. So afterwards for class I will write like this, okay, for simplicity. So one element is there. Can anybody tell me another element? Why this is so? Because the determinant of this value is class 1. Class 1 into class 1 minus class 0 into class 0, and this value is class 1. Any other element? Can anybody tell me any other element?
Sir, 1011.
1011. Very good. What is this determinant value? Again 1. Any other element?
Sir, 1101.
1101. Very good. Any other element? Any other element? Now just rotate this. So 0110. So give me any other element.
0111.
Very good. Just rotate this element. Any other element?
1110.
11. Sorry, 10. 10. Very good. Any other element? Any other element? You can check that you cannot have any other element. Now, can somebody tell me what is the determinant value of this? What
Minus
is so minus of class 1? Now in Z2, what is minus of class 1? Same as in Z2, what is minus of class 1? Okay, I am giving you a very simple rule how to calculate this. For example, in Z6, what is minus of class 2? What is minus of class 2? Quickly, can in Z6, what is minus of class 2? Okay. The simple rule is that you just add in, whatever be the n, try to make it positive. So here n is 6, just add them, because minus 2 plus n will be same as minus 2 plus n. So in case of Zn, this value is 0, right? So same as class 2. So here n value is 6. That means this is class of 4. Is it clear? This part is very easy. Minus of, say, class 3. What is minus of class 3 in Z6? Quickly tell me.
3.
Class 3. Very good. What is minus of 15 in Z16? Z6.
3, sir.
Again 3. Just make it, so you have to make it positive, right? So just add 3 of n. So that means 6 plus 6 plus 6, 18, and that gives you 3. That's all. So here also just class 2, that means class 1. So this all these determinant values are class 1. So all these determinant values are class 1, right? So now you can see that you have 6 different elements. Now somebody tell me, is this a group with respect to multiplication, of usual multiplication of matrices? Quickly, somebody. So you can check. So it's your homework. Please check that. Please check that GL2Z2 is a group with respect to usual multiplication of matrices. Okay. Now the question is, what is the order of this element and what order of this element? Quickly tell me, what are the orders of this element? So I will do the easiest part. The order of this is 1. Very good. Okay. Those who are having with even roll number, please do this. Who are having odd, do this. Or maybe 1, 2, 3, 4, 5. Okay. So roll number divided it by 5, whatever would be the remainder, do this. So I consider this to be 0, 1, 2, 3, and 4. So consider your roll number, class roll number, divide it with 5, and whatever be the remainder, do accordingly and find the order of this element. Quickly. And who doesn't belong to any of these groups, whatever you like, you find out. I must get some of the answers by now on. So how to find this order? Multiply it 2 times, then check what is its order. Somebody get any of the orders? Not yet. Anybody? Quickly. Okay, let's start with this 1011 1011. What is this value? This is 1, this is 0. So this is 1. This is 0, this is 0. This is 1. So this is 2, means 0. This is 0, and this is 0, and this is 1. So order of this element is 2, because this is the identity element. What's about order of this?
So, three, like the three number.
This one.
Yes, sir. That's three order.
Okay, its order, somebody says it's order 3. Its order is already 2, I have checked. So let's see with this 1101. Mind that all of them are in Z2. Okay, 1101. So this is 1, this is 0, this is 1, plus this is 1, 0, this is 0, this is 0, and it has to be 1, 1. So again, order of this is 2. What's about this? 0, 1, 1, 0, 0, 1, 1, 0. Somebody tell me, what is this value? This is 1, 0, 1. This is 0, 0. This is 0, 0. This is 1, 0, 1. So this value is 2. And hopefully this value will be 3. Somebody has checked?
Yes, sir. 3.
3. So what you can see is the orders of these elements are 1, 2, 2, 2, 3, and 3. Now, can somebody tell me anything that reminds you something that I taught you in my last class that reminds you this order sequence? Any
S
group?
S3.
Okay, S3. So again, we have seen, till now, we have seen 3 different groups. So S3, so elements looks like E, 1, 2, 1, 3, 2, 3, 1, 2, 3, 1, 3, 2. Okay. Then we have also seen D3, diagonal group, in a different way. That means E, R, R square, R cube, F, R F, R square F, having some properties like R cube equal to F square equal to E, and Fr equal to R square F. Also today we have seen that uh, DL2Z2, it also has 6 elements. Just now we have explained, we do not have uh, the space, proper place to write all these elements. But what we can see is that here also we had the order is 1, its order was 2, 2, 2, 3, and 3. Then what was the order of this element? It was 1. What was the order of R? It was 3. What was the order of R square? Can somebody tell me what was the order of R square? Okay, so I think R cube won't be here. R cube is already E. 1, 2, 3, 4, 5, 6. Yes, I did a mistake. R cube wasn't there. So what was the order of R square? Okay, make it R square, R square. That means R to the power 4. That
Three.
means R. And then R square into R square into R square. That means R into R square. That is R cube equal to E. So if you make it 3 times, that becomes E. So the order of R square is also 3. What was the order of F? It was F square equal to E, that is 2. What was the RF and R square F? Can somebody tell me what is the order of RF and R square F? RF into RF. RF into RF. Let's see. Fr is already r square f. So you can put this value Fr equal to r square f. So r square f into f. That means r cube f square, and that is E. So what is this order? Rf order is also 2. What is the order of r square f?
3.
Into r square f. You can check, it's somebody already mentioned, so you can check it. R square f into r into rf. So fr rf. So fr is r square, fr value is r square f, and that is rf. Okay, so this value is r to the power 4, that means rf into rf. Okay, just now we have seen that rf square is E, so this is E. So what do we get? So yes, so we have seen just now, it's a cross check, so it was E. So order of 1 3 3 2 2 2, and just now we have also seen in Z5, we also in GL2 Z2 we also have 1 2 2 2 3 3. So just try to compare these three things. In S3 we also had 1, then 2 2 2 3 3. In D4 we had D3, sorry, in D3 we had 1 3 3 2 2 2. So just try to compare, is it matching throughout? Though they look quite differently. One is S3 obtained from permutation, this is D3 obtained from symmetries on equilateral triangle, and this is obtained from matrices, but this sequence is same. There might be some permutation, but we can see that there are exactly three 2 degree order elements, degree 2 order elements. There are exactly 2 degree 3 order elements. Here also exactly 2 degree 3 order elements. Here also exactly 2 degree 3 order elements, and same. So this kind of things are all similar for all these three apparently different looking groups. And as I mentioned, when I will teach you the isomorphism, you will able to understand that algebraically, though these three groups different looks differently, they are basically the same. So they are all isomorphic. That means all the algebraic properties that you can think of, all of them will carry the same algebraic properties. So as a result, we do not distinguish these three groups algebraically. Though they look quite different, they are obtained from permutations, they are obtained from symmetries, and they are obtained from matrices, but they look exactly the same. So this is very important topic of algebra, and we will study maybe after 2 or 3 classes. Okay. So what we understand that if they are isomorphic, then it is sufficient to see that one of them is non-commutative. So this is non-commutative. As a result, this is also non-commutative. This must also be non-commutative. You don't have to think differently. Okay. Let us again come to another type of groups, that is, okay, in C. So we know that C is a complex plane. Suppose this is a complex plane. So you can, sorry, you can also write it in that way. So suppose this is my complex plane. So this is here R, this is also my R. Now suppose I have a point here. How do you represent in complex a point, some point? How do you represent in terms of say theta and R? Can somebody tell me what is the geometrical representation of some point in terms of theta and R? Somebody tell me. Suppose I have this distance from origin is r, and suppose this angle is theta. So then what is this point? How do you represent this point?
R comma theta.
R comma theta, okay, but r e to the power I theta, that you know? In complex analysis, you might have done this, that you know,
Yes, sir.
right? Okay. Similarly, if I have
Cos theta
another,
plus R sin.
sorry, yes, so you know, right? This r e to the power I theta, r, yes, in terms of cos theta and sin theta, you can explain. Now, suppose this is my theta 1, and suppose another point is there, say r2, say this is my r1. So this is my r1, and say this is my r2. So this is r2, and says this angle is theta 2. So r2 e at I theta 2, right? Now, how do you represent the product of these two elements? So r1 e I theta 1 into r2 e I theta 2. What was, how the product was defined in complex numbers? Tell me. How this is defined? Yes,
R1 is R2
very good. E to the power I,
theta 1 plus theta 2.
very good. So geometrically, how it looks like? It looks like something, say r is there. Suppose this is my, say this product of these two. Suppose this length is r1 into r2. So this length is my r1 into r2. Okay, and this angle, the whole angle here is my theta 1 plus theta 2. Okay, so now this point stands for r1 r2 e to the power I theta 1 plus theta 2. Okay, is this representation clear to all of you? I think you have already done this kind of representation in complex analysis. Okay, now suppose, again I am coming here. Now suppose I consider a circle with center 0 0, though it's not with center 0 0, but assume that this is a circle with center 0 0 and say radius r. So this point, this theta, if this theta is theta, say r theta 1, then r e to the power I theta 1. Okay, take another point. The value of this r will be the same because it's on the circle, but this angle, say theta 2, I theta 2. Now suppose I want to construct a group whose points are on the circle. Okay, try to understand my problem. The problem is I want to construct a group, okay, whose points are on a circle of radius, say r. Okay, now can you tell me what could be the value of r then? What could be the value of r? My intention is to find a group such that the group consists of all points on a particular circle of radius r. Now my point is, what could be the value of r? Anybody? Try to understand. If it would be a group, then the closure property must be satisfied. That means r into r, that means if you make a product of these 2 points, then this product will also be within that circle because my G will consist of all points on the circle. That means if you make this and this product, that should also come to my on this circle. If that could be the case, then what could be the value of R?
1.
Equal to 1. 1.
Exactly. So now you can understand, to have this a group structure, I must have R to be 1. Okay. So I consider all such complex numbers z belongs to C such that mod of z equal to 1. Now you can understand what do you mean by mod of z equal to 1. That means r equal to 1. Okay. So now there is no concept of r because this value of r is 1. Now you can understand very easily, if I multiply this 2, then that may come here. And this value will be e to the power I theta 1 plus theta 2. And if I consider all such points with respect to multiplication of complex numbers, then you can show that this is a group. So your homework is this G is a group. And this group is known as S1. So this is a circle and that is known as circle group. Circle group S1. Is it clear? So you need to check whether all the properties of this elements are, all the properties of groups are satisfied for S1. So what is S1? S1 is basically all such complex numbers whose mod value is 1. That means it will be a circle. Mod value is 1 means the R value is 1. So it's a circle on the or in the complex plane whose radius is exactly 1. And that's a group. So question is, all the properties that you have encountered till now, is it infinite or finite? Is it finite? Is it a finite group? What do you think? This group is a finite group or infinite group? What is your intuition? This group is finite or infinite group? Quickly.
Sir, infinite.
Good. So this is finite group. That means this is false. Is the group commutative? Is the group commutative?
Yes, sir.
Yes, sir.
Because
Yes,
you
sir.
can interchange this plus theta 1 plus theta 2 equal to theta 2 plus theta 1, and as a result, so this is a commutative group. Is the group cyclic? That is interesting question. Is the group cyclic? That is interesting. That you need to think. So this is your actual homework. Next class you will tell me whether this group is cyclic or not. So you have seen that this is an infinite group, this is an infinite commutative group. Now the question is it cyclic? If this is cyclic, then you need to give me the generator. And if it is not cyclic, then tell me why this is not cyclic. Give me an element which cannot be generated by some other element, by a single element. Okay. So that's quite interesting group that you need to think about. So this group is basically a group within this complex. So non-zero complex number with respect to dot, we call it, this is a group. And afterwards in the next class I will talk about subgroup. And there you will be able to understand that S1 is a subgroup of C star dot. So it's a non-zero complex number with respect to dot. In the next class I will show you that S1 is a subgroup of this sister dot. Okay. So till now whatever I told you, is it clear to all of you? If so, or if you don't have any question, you are free to ask me.